Begin with this minima and maxima. Okay, so obviously this is a plural to minimum and maximum. So that's what it means. Okay, right. So let's say first of all we have a function of this. Let's say x squared minus 6x plus let's say 5. So when you have a function like this, obviously come this way, you are like half expert or more than half expert, so you should know what this is. So what kind of function is this? Quadratic. Since we're talking about, we are on the subject of minima and maxima, so obviously you know, is this a minimum or a maximum? Is this a minimum or a maximum? Are you sure it is minimum? Okay, so it must be minimum, right? It must be minimum, right? How did you know that it is a minimum?
A is more than 0.
Because A is positive, isn't it? So A is the coefficient of x squared. Yeah, the coefficient of x squared here is 1, so 1 is obviously positive. Yeah, so you know that this is a minimum curve. So it has that particular point. What is the name of that point where this minimum occurs? A turning point. Do you know any other name? Stationary point. Okay, so that's what it means here. Now what we want to do is actually use dy dx to work this out. Okay, so if you do a dy dx here, what is the dy dx of this? 2x minus 6. Okay? Yes? Correct? Okay. Now, when you do dy dx here, the dy dx actually also tell you where this turning point occurs. Okay? Why is that? What does dy dx tells you? The gradient, right? So, let's say if this is a quadratic, what should the gradient be for a turning point to happen? It must be a 0, right? Meaning, it must begin from, let's say, negative, and then it must go to 0, and then positive again. So that should give you a minimum curve, yes? Yes? Okay, so if it is a positive and then 0 and then go back to negative, then you know that's a maximum. Okay, because that's how the gradient is supposed to move. Yes? Alright? So in this sense, then you are going to say, okay, if dy dx equals to 0, so when does this occur? This occurs when x equals 3. Okay? So this tells you the x coordinate of the turning point. Okay, so the x coordinate of the turning point is 3. So that means when x equals to 3, this is where the turning point is. Okay, right? Then the next thing, how do you know that it is a minimum or a maximum? Now we need to do this thing called a second derivative. So the meaning of a second derivative is you differentiate dy dx again. Okay? So if you're going to differentiate again, so this is how you write it. It's called, again, there are many ways to say this, and I would prefer to say it as d2y instead of a square, alright? Just to differentiate. Again, this is a symbol. Okay, so it is d2y dx squared. So you differentiate this again, that means you differentiate 2x minus 6. So if you differentiate with respect to x, 2x minus 6, what do you get? You get a 2. So what we're saying is the second derivative is greater than 0, therefore this is a minimum. Okay, let's try another example. Let's say you have another function that is this way. So y equal to 3x squared minus x cubed. So we're going to evaluate whether or not there is turning point, or they are turning points, and then how many there are. Okay, so what do you do? So again, the steps that you should be doing will be the first one to do dy dx. Okay, so you differentiate this. What do you have? You have 6x minus 3x squared, yes? Okay? And then what do? You're gonna let dy dx equal to 0. And then you're trying to find at what values of x that dy dx equal to 0, yes? Okay, so dy dx is, what is dy dx? What does dy dx equal? What does dy dx equal? You want to make it 0. So what does dy dx equal? So it would be 6x minus 3x squared equals 0. Okay, so what do you need to do? You need to factorize it. Minus x, yes? Correct? Yeah? So x must equal 0, or x must equals to 2. Okay? Alright? So that means at these 2 points, a 0 occurs. A 0 occurs for dy dx means the gradient has become horizontal, or that particular, the gradient of that tangent has become 0. Yeah? Okay, so then what you need to do? You need to do a second derivative, d2y dx squared. What does it equal? 6 minus 6x, yes? Okay? Then you need to do both of them, yeah? So when x equal to 0, what is the second derivative? Equals to 6, yes? Is 6 greater than 0? So it is. So greater than 0. So if the second derivative greater than 0, what does it say? It has a minimum occurs here. Okay? And then you have to do it another time. So when x equals to 2, then the second derivative is 6 minus 12, which is negative 6. Is negative 6 greater than 0? No, it is less than 0. Therefore, you have a maximum. Okay? So in this particular function of 3x squared minus x cubed, then you know that there are 2 stationary points. Okay? So one is the minimum, one is the maximum. So the minimum occurs when x equal to 0, and the maximum occurs when x equals to 2. Alright? So just to continue from here, what are the coordinates of this stationary point? Okay? So you say for the minimum when x equals to 0, yes? So the function is y equal, what is it? 3x squared minus x cubed, yes? So when x equal to 0, y equals to 0. Right? So the minimum point is 0, 0. Okay? So the turning point, the turning point, which is minimum, occurs at the coordinates of 0, 0. Okay? So what is the other one? The other one is when x equals to 2. So when x equals to 2, so what is y? Y equal to 3 times 2 squared minus 2 cubed, which is 4, yeah? Okay. So the point, so then this is maximum, yes? We worked out earlier. So the maximum point is 2 and 4. Alright?